y2 minus y1 over x2 minus x1. So 56, 40, 24, right? 24, 8. $56, 40, 24, 8, negative 8. Is that what you guys got? And then negative 24, negative 40, negative 56. And how are we calculating these numbers? Talk to the person next to you. How are we getting these? How are we punching these numbers? Here's a graph of them, of all those points. And you could do a linear regression off of these. And if I did a linear regression, stat, calculate, number 4, linear regression this time, I get negative 32x plus 64. If I wanted to graph that, VARS, statistics, EQ. So what we just did was we actually calculated the equation for the derivative, the derivative function, just by finding little average velocities. Does that make sense, you guys? A total approximation, we said, okay, this is a bunch of data, but I'm going to find a bunch of just averages and just plot them in between, just to get kind of a rough sketch, just a general rough sketch of what the derivative would look like. Does that make sense, you guys? And if you look, actually, this worked out pretty good in this case. This is actually exact data, and it's always not going to be, but this is actually exact data. So we got the derivative was our derivative function by hand. Do you see that? But what we did was we did it all without any sort of calculus tool. It was just plotting a bunch of average rates of change to get sort of a look at what the derivative would look like. Does that make sense, you guys? Sometimes you just kind of like, I know, roughly what's happening with this thing. Where is it going? And here's a way to do it. How are we feeling with this? Yeah?
How do you get it to go straight into y?
Great question. So, if you get it to go straight into y, first you go to your y equals screen. On your y1 you hit VARS. Go down to number 5, statistics. Go over to EQ, and then hit enter on 1 reg EQ. And it'll dump it right in for you. So you don't have to retype it. Some of these things are going to be messy. You know what I'm saying? So you don't... I didn't know you were telling me. So you don't have to retype it every time. Okay? Yeah?
Why are we going with the interval we are at like 0.25 to 0.75?
So that's your y plotted at 0.25, right?
Yeah.
Well, what we were doing was we found the average between 0 and 0.5, so we just need a place to put this. Could we put it at 0? Sure. Could we put it at 0.5? Sure. But I'm just going to put it in the middle. You know what I'm saying? Like the average on this interval from 0 to 5 was 56. Now I just wanted a place to put where that average was. So I just put it in the middle between 0 and 0.5. There's no really rhyme or reason for it. It's just a place to put it. You can put it, if you wanted a rough...
Would it work if you put it at 0?
So you're wondering why it's exact?
No, I'm just wondering why, we'll put it in the middle when you take it.
Well, because between 0.5 and 1, we got another value. You know what I'm saying? So for that new value, well, how does it, do we put them both at point? Well, we can't put them both at 0.5. Should we put the first one at 0.5? Okay, fine. And then put this one at 1. You know what I'm saying?
We could do that? Like, we could put the first one.
Well, sure, yeah. It's just to get a rough sketch. You know what I'm saying? Like, you can put them all at 3/4 of the way in the middle. Why half? Because it's kind of like you found on an interval, like an average. So we just like put it in the middle, and that's what we did here to get a rough sketch. You can put it. There's no rhyme or reason. There's no exact science like to this specific sketch. It's just a tool to get around taking the derivative off of data. Does that make sense? I mean, good question. It's like, well, why? And it's like, well, just kind of it's a place to put it, you know? Because I don't actually have no idea what's happening at 0.25. And if this wasn't in time, you can't actually assume anything about 0.25. You know what I'm saying? I don't have a data point on 0.25, so I can't make assumptions about it. And we'll get into that later, which is a good question. I don't know anything about 0.25. But for an average, I just stuck it somewhere. Okay? Does that make sense? All right, let's do this. I want to do another parametric problem. So a couple of more problems on the homework tonight. You're going to deal with parametrics. So let's do another. So on the time interval -5 to 5, I have a function that's moving. X position is following 3 minus absolute value of t, and your y position is following t minus 1. Okay? So I'm just going to by hand sketch some points for this to find out what's happening. So let's see here. Make a nice little sketch. And I'm going to make a little table too. So at time I want to know specific x, y values. Again, parametric mode, you plot the x position and y position independently according to time, but then you still plot the point as an xy point. Does that make sense? So at time -5, where's the x position at? And how did you figure that out so mathematically quick? Yeah, put -5 into here, that's 5. 3 minus 5 is -2. What's the y position? At time -5. -6. So we can plot that on our little graph here. 6. -2, -6. There it is. Here I am at time 0. What's your x position? Your x position's 3. What's your y position? -1. Okay. So at time 0, your point where you are in space is at the point 3, -1. Okay? And you move this way. You're doing that. And now at the point 5, when I finish up, where's my x position? At 5, you're back at -2, but what about your y position? At time 5, you're at a time of 4. Does that make sense what I'm doing here, you guys? Yeah? Okay, so now you're up here, -2. You're here. So you started here, you've gone this way, and then you bounce back going this way. So that's where you're moving. You're plotting this little bug, this little particle moving around. According to time, this models the x position, and this models the y position. Okay? And I want to know the equation of the tangent line at time let's say at time, I think -3 would be nice.